Hello, and welcome to this presentation, Decoding MIL-STD-1553 with MXO series oscilloscopes. In this presentation, we'll show how to use Rohde Schwarz MXO series oscilloscopes to decode MIL-STD-1553 serial data. This presentation assumes a basic familiarity with the operation of MXO series oscilloscopes, as well as a basic understanding of the MIL-STD-1553 protocol. If you're unfamiliar with either of these topics, or if you'd like a brief review, you might want to watch the presentation Getting Started with MXO Series Oscilloscopes and/or the presentation Understanding MIL-STD-1553 before beginning this presentation. Rohde Schwarz MXO Series Oscilloscopes support a wide variety of serial decodes, and MIL-STD-1553 decodes are enabled by the software license K530. Decoding can be performed using any of the analog channels. In addition to basic display and decode of MIL-STD-1553 serial data, the MXO also supports numerous other useful functions. Words can be shown individually or in a table, and user-friendly or humanly readable labels can also be easily imported. The MXO can trigger and filter based on MIL-STD-1553 field values or on error conditions such as parity or gap errors. Decoded frames can also be exported in a variety of formats. The first step in decoding MIL-STD-1553 data with the MXO is to select bus from the list of items in the bottom right corner of the screen. Then select MIL-STD-1553 from the list of available protocol types. This will also create a small box labeled MIL-STD-1553 in the signal bar near the bottom left corner of the screen. This box can be used as a shortcut for configuring decode parameters. The next step is configuring the source channel, and this is done under Setup. As you should already know, MIL-STD-1553 is a differential bus consisting of two wires, and these wires can be probed in two ways. A differential probe connected to both wires is the preferred method of probing the bus, but in some cases a single-ended passive probe can also be used. The polarity setting selects normal or inverted polarity. Note that other channel parameters, such as the probe type and parameters, are chosen and configured through the standard MXO channel configuration menus. This might be a good time to pause for a moment to talk about channel settings. Before starting decodes, it's always a good idea to first check that the signal or waveform is correctly on screen. In this example, the signal appears on the screen with appropriate vertical and horizontal scaling. The most common issue in serial decoding is incorrect vertical and horizontal settings, such as the wrong time base or the wrong volts per division setting. So it's best to visually verify that these are set appropriately. Another potential issue in serial decoding is too small of a sample rate. At least 2.5 times the dot clock rate is the standard recommendation, but note that this is only 2.5 megabits per second for MIL-STD-1553. After verifying that the input channel levels and time base are configured properly, the next step is setting thresholds. These are voltage values that differentiate a logical 0 from a logical 1. Here, the upper threshold is set to 4 volts, and the lower threshold is set to -4 volts. Enabling Show Threshold lines can make it easier to determine whether these thresholds are configured correctly for the measured bus signal. Once thresholds have been set properly, decoded MIL-STD-1553 words will be displayed together with their analog waveforms in the upper portion of the screen. The lower portion of the screen contains the result table, which shows summaries for all of the decoded frames within the acquisition. The display settings can be customized in a variety of ways. The decode table can be turned on and off, and we'll look at the decode table more closely on the next slide. The decode layer is shown along the very top of the screen and can be set to off or to several other formats. MIL-STD-1553 uses Manchester 2 encoding, and the edges or transitions, that is from high to low or from low to high, can be displayed above the analog waveform. Alternatively, the interpretation of these symbols as bits, logical zeros or ones, can also be selected. The default format is showing the data as entire words, with each field having a different color. These fields can be displayed in different base formats, such as decimal, hex, etc. Rather than viewing MIL-STD 1553 words as numeric values, it's also possible to display these in a more human-friendly format. This is done using a MIL-STD 1553 label file in CSV format. Each label is on its own line, consisting of the RT address, RT label, subaddress, and subaddress label. Our example file here maps the RT address 1 to the label engine, and subaddress 1 to the label thrust. These labels are then used in the decode summary as well as in the results table. Now let's take a closer look at the decode table, which is typically in the lower portion of the screen and which shows detailed information for each MIL-STD 1553 word. This table contains information on a per-frame basis, including the index, which is the word or frame number, the state, which shows if the word is errored or not, and the start time of the frame. The type of word, command, status, or data, is shown with the frame information and the RT address. Note that the parity bit is not explicitly shown, but parity errors will be indicated in the state field. For data words, the data field is shown in the user-selected format, and the data rate of the word is also displayed. Our next topic is triggering. Although it's possible to trigger using only standard waveform type triggers, the MIL-STD 1553 software trigger provides advanced functionality. To configure this, we must first configure a standard trigger type, such as an edge trigger, and then a MIL-STD 1553 specific trigger. The software trigger can be configured to trigger on specific word types and field values, as well as to trigger on error conditions, such as gap errors or parity errors. Let's look at an example. Here we've configured our MIL-STD 1553 software trigger to trigger on words with an RT address of 06, and the capture therefore triggers only on frames that contain this specific RT address. Filtering is similar to triggering in that it identifies frames that meet certain user-defined criteria and then only displays those frames. As with triggering, the specific MIL-STD 1553 fields, or field values, can be selected and configured for use as filter criteria. Filtering only on different error types is also supported. Note that the values for a field can be entered as specific values or as a range of values. Here's a quick example. With no filtering applied, our decode table shows MIL-STD 1553 frames with many different addresses and word types. Applying a filter for command status frames with an RT address of 06 causes the decode table to show only words matching this specific type of frame and this specific RT address. Before we conclude this presentation, it's worth mentioning that decoded results can be exported by choosing Export from the Serial Bus menu. The supported export formats include HTML, CSV, XML, and Python. The CSV example shown here shows the types of data in the export. This includes timing information, as well as the decoded values for each individual frame. Let's end with a brief summary. The K530 option enables MIL-STD 1553 decodes on MXO series oscilloscopes. All MIL-STD 1553 protocol parameters are user configurable, and decoded data can be displayed in various formats, with both the waveforms and in a decode table. The MXO also supports a wide variety of trigger and filter types, such as specific values or ranges of values in the frame fields, and/or on frames having different types of errors. A label file can be imported to show more humanly friendly labels. Decoded serial data can also be exported as CSV, HTML, and a number of other formats. And finally, Remember that it's a good idea to check basic oscilloscope settings, such as levels, thresholds, time base, etc., before starting decodes. This concludes our presentation, Decoding MIL-STD-1553 with MXO series oscilloscopes. If you'd like to learn more about serial protocols, decoding serial signals, or Rohde Schwarz oscilloscopes, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.